So this is the 4 LED bounce chaser ingredient list. So we have our USB AB cable, we have our breadboard, we have our 220 ohm resistors, and it's up to you to look up the codes, color band codes for the resistors to determine the resistance for the resistors. We have red LEDs. It doesn't matter what color you use. We have some jumper wires for the signal lines, and these jumper wires, you can see, have a prong or pin at both ends. We have longer jumper wires. One's black in this case and one's red, and I'm using that standard where red means positive voltage and black means ground. We have our Arduino Uno Wi-Fi revision 2. And these are the ingredients that we need in order to carry out the 4 LED bounce chaser experiment. Now this is a breadboard. A breadboard is used for prototyping circuits without committing to soldering. And to use a breadboard, it's important to understand what the electrical connections are on your board. Now, a breadboard you can think of as having rows and having columns. You can think of a row in this configuration as going from left to right in that direction, and a column as going from front to back in the other direction. So you can imagine it as a two-dimensional coordinate system describing the breadboard. Now, for the breadboard, one of the things you'll notice here, within a column, you have a gap down the center. Now, for this gap down the center, we'll notice these pins that are labeled, or these holes that are labeled A through E and F through J. Now, when you go in a single column, we have this column, that first column, in a breadboard, all of the pins that you plug into, or wires you plug into each one of these holes on the breadboard, they're all electrically connected. And so if you plug in a wire here in position E and here in position A, that's going to be the same as if you connected those two wires together. So there's a conductor running along each one of the columns for A through E position, and there's a separate conductor running down the column for the F through J position. So everything in this trench, or gully if you want to call it that, is isolated. So it's almost like someone took a wire and they laid it down here, cut it, and laid it down here. And so you're going to use these positions in each column to connect things together. Likewise, if we see along the outer parts of this breadboard, along here and along here, these connections are a little bit different. So we'll notice we have 1, 2, 3, 4, 5 holes. These holes, when you plug in a wire, they're all electrically connected, but the conductor underneath these holes doesn't just run the length of the holes for connections, it runs the entire length of the board. And so for these rails here, we'll call them, imagine you had a single wire or conductor that ran underneath all the way down the edge of the board. There's a separate conductive pathway in this other row that runs all the way down the row on the board. And so you'll notice that you have a marking of plus and a marking of minus. And what these traditionally are used for are the rails, so to speak, that you tie in the supply for voltage. So on the plus, you would put the positive voltage lead. On the minus, you would connect your ground. And so this is how you get power onto the board. And then you would take one of your, say if your component needed a positive 5 volts, you just connect your positive 5 volts to one of these columns here. that your component is plugged into. And so that is a little bit about the conductive pathways for the breadboard. And so when we start out with the Arduino, one of the things we're going to do is we're going to take our power, and we can see here you have plus 5 volts here, and you have ground here. So you're going to take a jumper wire, and you're going to run plus 5 volts to one of the holes for this positive power rail, and you're going to take ground, a jumper here, and run it to the minus rail. And you could do it on either side. You could do it on both sides, or if you run it to one side, you make a jumper from positive here to positive over there, negative here to negative over there, in order to feed the board both sides, because you're going to have components on both sides. And so that's a little bit of a walkthrough of the conductive pathways for your breadboard, but how you get it from your Arduino, because in this case, we have our plus 5 volts and our ground. Okay. Some tips for how you put in your resistors. So what I like to do, is I put about 2 or 3 spaces between my resistors. So here we have these resistors in the column, and I'll say 1, 2 spaces away to give it some room. So you take one of the pins, one of the prongs, you push it, see if I can get on camera, into the breadboard. All right, you're not going to really jam it tightly, and you'll notice here it's standing up. Then I take the other conductor, the other lead as it's called, and I kind of bend it a little bit. See if I can do this with one hand while I'm filming. And then I'm going to bend it down gently, because if you mangle it, it might break, and you push it down into the positive rail. And so here, this is what it looks like up close. And now I'm going to take my red LED, last one, and for the red LED, the anode, or the positive lead, is the one with the longer leg. I'm going to stretch out the space between the legs a little bit, and then I'm going to put the longer lead on the positive side, because we have plus 5 volts going to the resistor, and then the resistor in series with the LED. So let me get a little bit of a close-up here, and I'm going to put the anode or positive lead in, and then kind of spread it out a little bit, and the cathode, negative lead, goes in, push it down. And you see they look like this. And so what we have here, we have our positive rail, our plus 5 volts coming from positive 5 volts on the Arduino, a jumper wire coming up, and it comes down into the positive rail. That positive rail feeds each one of these resistors, and then it goes positive through the resistor. There's a conductor connected in series with the LED. They're connected together, and then the LED comes over here, and that's going to be the negative side to go to negative. And so what will remain then is I take my ground, instead of having it there, I'm going to put it over here so that all my grounds are on the other side. So now I have my positive 5 volts feeding these resistors, going to the diodes, and then going to ground. Now I have a constant 5 volts going in. I haven't connected the signal lines digital I/O. Now what we're going to do is we're going to have digital I/O drive the voltage for the resistor and then the LED going to ground. But now I'm just connected to 5 volts to show you these LEDs once they're lighted. So I'm going to go ahead now, and I'm going to plug in my USB AB cable. We have that. So let's go ahead now and connect our LEDs to ground. We have ground from our board. We have the 5 volts from the board, but we're going 5 volts through the resistor, connected to the diode, the LEDs. Now these LEDs, their rails go all the way, these columns, out to the edge, but we're not connecting them to ground. So let's go ahead and connect them to ground. Okay, so this is the fully connected circuit. We have our Arduino board, and we're using the plus 5 volts jumper to drive the positive rail. We're using the ground jumper to drive ground or negative on the breadboard. And then we go from plus 5 volts through the resistor, and I'll just do it from the perspective of one of them. Plus 5 volts through the resistor, connected to diode, the anode plus side of the diode, to the cathode, the minus side of the diode. The minus side of the diode is conductive on that column that it's in. And then we have a black jumper, and that black jumper connects to this negative rail on the edge of the breadboard, and then that goes to ground, which is shared with or provided by the Arduino. And we have our LEDs lighted. Now, the only difference between this and the LED bounce chaser is that instead of driving the whole thing with 5 volts to keep them on continuously, we're going to drive them from the digital I/O lines, which are here. And you just pick 4 of them. Okay. This is the finished product of sorts for the 4 LED bounce experiment. And as you can see, 4 LEDs are lit, traveling, going from left to right to left to right, effectively bouncing from the left extreme, or if it's lighted at the right extreme. And so here, I'll highlight a couple things. I've incrementally changed my setup from the previous setup where I had all of the LEDs lighted using 5-volt tie point. So here we have the Arduino Uno Wi-Fi, and you can see here we have a jumper going from ground up to the negative rail or ground rail on the breadboard. We also have our 4 signal lines. I've selected them to be orange, and my signal lines I've connected to pin 10, 11, 12, and 13 for the digital I/O. Now, on the right, we have pin 13. So this would be pin 13, 12, 11, and 10. So I take these, and these digital I/O lines, remember with digital I/O, a logic 1 is plus 5 volts. So this digital I/O is programmatically turned on and off to light the LEDs in a pattern, and we drive this using a finite state machine. And so here we have digital I/O line connected in the same column on the breadboard to a resistor. There's the resistor. It comes down, and that resistor comes down in the same row as this first LED. So going from left to right, we're saying this is LED 1, 2, 3, and 4. So we have a resistor for this digital I/O pin feeding to LED 4. This digital I/O pin, here's its resistor, feeding to resistor 3. This I/O pin connected to this resistor, feeding LED 2. And then this last digital I/O pin, that jumper, which is, in my case, digital I/O pin number 10, connected for that column. It's an electrical connection to this resistor. Resistor hops over to make an electrical connection to the anode, the plus side of this LED. It jumps over this gully, so to speak, and it connects to this ground rail using the black wire looped over here. And so in a finite state machine, we cycle between LEDs 1, 2, 3, 4, then 3, 2, 1, 2, 3, 4, 3, 2, 1, continuously. All right, so that's the finished product that you'll all be building.